All right, moving on here to the end of our review. Let's look at a couple of word problems here dealing with exponential growth and decay. Looking at our continuous exponential model. Here in number 21, it says a certain culture of bacteria has a population of 340. Population grows according to a continuous exponential growth model. After 9 days, there are 544 bacteria. Find the daily growth rate. Give an exact answer and not a decimal approximation. So we're looking at this problem here. Right? The key word here is a continuous exponential growth model. So with that said, our model, right, is A of t equal to initial amount, a sub 0, times e to the r times t. All right, so this is a natural exponential function, right? I got our natural number e as our base because it's continuous. That's the key word. With that said, we were given an initial population of 340, right? And it grows eventually after 9 days to 544 bacteria. All right, so let's go ahead and talk about that. So with that said, we're given a sub 0 equal 340, right? Initial amount. And then we're also given after 9 days, right? So we're given a future amount here. So we're given our t value, all right? So after 9 days, that implies a of 9, the amount in 9 days, end up being 544 bacteria. All right, so let's take that, let's plug it into our model. So with that said, this is our continuous exponential model. If a of 9 equal 544, 544 equal to an initial amount, 340, times e to the r times t, which is 9. Right? So you can see in this model, we've got one unknown. That unknown being the rate, what we're trying to find. Right? It says find that daily growth rate. Find that value of r. So let's go ahead and solve it. Now we're solving an exponential equation. And to solve an exponential equation, we want to isolate the exponential term, and we'll introduce logarithms to solve it like we've been doing in our previous equations. So yeah, we got to get this exponential term by itself. So let's go ahead and isolate. That'd be our first step. So we'll go ahead and divide 340 on both sides, right? Isolating the term. And maybe we should make that note here on the side. Isolate exponential term. All right, now as we do that, right, now our equation reads, 544 over 340 equal to e to the r times 9, or 9r. Okay, well now, right, we're going to introduce logarithms. All right, let's see if we can get us a little more room here on this one. All right. So step 2. So we know in this problem, we're not going to be able to bring down r using the same base property, exponential properties. We're dealing with our natural numbers. No way to rewrite both sides with base e. But we can apply logs. So again, we want to use log properties to help us solve. All right, so let's take natural log. All right, log base e of both sides of the equation. All right, so to do that, we'll write that in here. So we're going to take the natural log on both sides. All right, so as we do that, all right, we've got the natural log, and let's just write it. We'll go ahead and we'll put that in our next step. We'll show work here. So the natural log of 544 over 340 equal to log base E. Remember, it's abbreviated natural log ln is log base E. And the reason I'm taking log base E, I can take any log I want on both sides as long as it's the same base. But the reason I'm doing log base E is because I'm dealing with my natural number E and my exponential. So it allows me to use my composition property or my same base property that we learned in our log properties section. So let's simplify now. So remember, right, we know that log base A of A to the x power always simplifies to x. So we can apply that here, right? So we want to go simplify. So as we do that, we apply that property, right? That implies we got the natural log of 544 over 344 equal to 9r. Right? Natural log of e to the 9r, that's log base e of e to the 9r power. So they wash out, right? That simplifies down to our exponent, right? Which our exponent is what we were trying to bring down. It contains our variable, our unknown, r. So that's using our simplifying property, right? And we'll make a note here. And what kind of equation now are we solving? I mean, this is a linear equation. We want to solve for r. So in our next step, we're going to go ahead and divide out 9 on both sides, right? We'll have our solution. So as we divide out the 9 on both sides, right, here's our answer. Let's go ahead and show our algebra. So what does r equal, which is what we were looking for, our daily growth rate. That implies r equal the natural log 544 over 344 divided by 9. Right? Now that's the exact value, right? We found our exact, right? And you could simplify a little bit. Like I said, if you wanted to find the approximation, you could, right? So again, that's something we could do right now if you want. Get your calculator out. And let's put it in our TI. So again, what is the natural log of 544 divided by 344 divided by 9? All right, you're looking at what? 0.05, right? As a decimal, if you round into the nearest hundredth, 0.05. So let's go ahead and write that in here. 0.05, which is approximately what? 5%. So that's your rate there, right? Your daily growth rate. So we're trying to find r, right? Which is what we found there. And they want it as exact, so we'll leave it in that fraction form. But if they want it written in terms of a percentage or rate, we go ahead and type it in and get the decimal and convert it over to a percentage. So 5% growth rate at this continuous model. All right. Now